All right, 4.1. 4.1 deals with rational expressions. Rational expressions mean that your exponent is a fraction. So rational expressions just mean that a fraction is your exponent. Okay? So it says each rational expression can be written as a radical expression and vice versa. So we're going to deal with radical and rational. What do you guys think of when you think of radical?
Like Radical Ninja Turtles.
Like Radical Dude, Teenage Mutant Ninja Turtles. Okay, what about math? It's concerned. It's underneath the radical. It's that symbol. So the word radical in math, the word radical means this symbol. All right, Josh. I mean, Justin. Is she coming? Belinda?
No, she left.
Okay, so let's look at this. It says this form x raised to the a over b. So a over b is a fraction. All right, so a over b is a fraction. Please notice that if we want to write it as a radical expression, the denominator becomes the root. You guys see that? It moves from being in the denominator to being the root. The numerator stays and becomes the power of that variable. So the numerator stays, the denominator becomes the root. So if you need to make yourself a note of that, the denominator is the root. The numerator is the power. The denominator is the root, the numerator is the power. So we're going to do some examples where we're going to go back and forth. So let's look at what they're asking us to do here. Number 1 says write each expression in radical form. So all we're doing is writing it in radical form. We remember that the denominator becomes the root. So I will have the 5th root. Please make your 5 small like that. Sorry.
Yeah.
It should not look like this, because that is a coefficient in front. It needs to be a little 5. What's the constant underneath the radical? A 6. What is the exponent of the 6? The 1. Now, do we need to write the 1 there? No, but for this example, I would like for you to write the 1 there so that you know where it's going. Okay? All right, that's it. Just rewriting it in a different form. Now, number 2 says what? It's the 1/3, so what becomes the root?
3.
That 3 becomes the root, right? So we have the cube root. What goes underneath the radical?
4.
The 4x, right? Now, if the 4x is in parentheses, because if I put my 1 out here, right, if I put my 1 out there, is x being raised to the first power? Or is 4x being raised to the first power?
4x.
It's 4x, right? But if I don't put parentheses around 4x, what is the only thing being raised to the first power? All right, do you see how that's really important? If it was a squared, especially, it would be important, right? So if there are parentheses, you need to make sure you put the parentheses around. Because otherwise, you're telling me that just the x is being raised to the first power. Try number 3 and see if we can come up with the same answer. You try number 3. What do you think the answer for number 3 is? And then reduce your fraction.
Oh, you reduce it?
Always.
Okay.
Okay, so 5 comes out to be my root. So I have the 5th root. What stays underneath, Anthony? 5c. Is that in parentheses or no? Okay, and then what is my power, Chris? 2. Your radical symbol should go the entire length there, so that everything should be in it. Raise your hand if this is what you have. Excellent. No, we're not going to solve it. We're just working on rewriting it out. And the directions in your homework will say just to rewrite it in the other form. If it wants you to solve it out, it will say evaluating. That's what we're going to do on problem number 7. So for right now, we're just rewriting it. So example 4, so now we're going to go backwards. So on example 4, my root there is a 4. So that's going to become, good, the denominator. So I have 26. What's the numerator? Excellent, 1, because it's 26 to the first power. Remember, your 1/4 should be small. It should not look like a big number, like 26 and 1/4. It should be a small exponent.
You're just rewriting that as like a fraction, kind of like number 1.
Correct, we just went the opposite direction. Yep. Okay, number 5. I have a cube out there. So that becomes my denominator. So I have 6x to the 5th, y to the 7th. Now, if I put my denominator here, what's the numerator? It's not 7? The 5 and the 7. This one's kind of a tricky problem. Would you agree that underneath the radical, I really could have this whole thing raised to the first power? Okay? So my numerator is going to be a 1, but what do I need to have in this problem? What am I missing in this problem? Good, parentheses, because right now it looks like just the y to the 7th is being raised to the 1/3, but I want this entire thing raised to the 1/3 power. So keeping that in mind, why don't you try number 6?
I think I got it now.
Good. Anybody want to give me their answer on number 6? Brianna? 5x squared y in parentheses to the 1/3 power. Does anyone echo that? Raise your hand if you echo that. Excellent. Excellent, excellent, excellent. You guys hear my echo? Okay. All right. Any questions on 1 through 6? Just rewriting them. You okay? Again, your directions in your homework will be very specific. It'll say write in radical form or write in rational form. Okay, so it'll tell you what you need to do. So let's look at examples 7 through 9. So this is where we actually are going to solve it out, if you will, which is called evaluating. Oh, 7 through 12. Haha. All right. On number 7. What I want for us to do is I want us to change this into radical form. Okay? So I have 125 to the 1/3 power. So if I were to write this in radical form, it really is going to be the cube root of 125. Now, you can use, what'd you say? No, you don't have to put the 1 because that just means that you only have 125 underneath there.
I reduced it to 5, so would you put it at 5?
You could, yes. So, we're going to work this out. Your answer is correct, yes, but I want to talk about this. Do you guys remember a couple weeks ago we did this, like the square root of 40, right? And we'd break it apart like that. Do you guys remember doing that? And we were looking for groups of how many things? 2 things went in my group, right? Why did I have 2 things in my group? Because it's the square root and there's a hidden 2 right there. So with 125, and I'm looking for the cube root, how many things do you think should be in my group? 3, because it's the cube root. So let's just, like normal, break 125 down. So I can break 125 down to be what? 5 and 25. All right, so everyone do this. And then 25 can be broken down to what? 5 and 5. Can we break anything else down? Okay, again, remember, I'm looking for a group of 3 things. And boy, isn't that convenient.
3 5s.
I have 3 5s. For every pair, we only write it how many times? Once. So I have one group of 5, so that means I'm only going to write 5 as my answer. So whatever the root is, that's how many things need to be in your group. So let's hop over to number 9. We'll come back to 8, but let's hop over to number 9. And it says 81 to the 1/4 power. So if I write 81 in radical form to the 1/4 power, that's going to be the 4th root of 81. Okay, it is a perfect square. But on number 9, again, write it as a radical, the 4th root of 81. So how many things are we looking for in our group this time? 4 things. Okay, so let's just break 81 down like normal. What makes 81? 9 and 9. What makes 9? Well, that's 3 and 3 and isn't that interesting? We're looking for a group of how many things?
4.
Okay, I heard like 7 numbers there. We're looking for a group of 4 things because this 4th tells me you need 4 numbers in your group. So I have 4 3s in my group, but for every group we write it how many times? Once. So the 4th root of 81 is the number 3. That means 3 times 3 times 3 times 3 is 81. That would be your final answer. All right, let's look at 27x to the 2/3. Is that what that says? Yeah, 2/3.
Oh, we're going back to number 8.
Yep, we're going to hop back to number 8. So, the only difference about this is that I have a variable. So, the first thing we're going to do is we're going to, quote, kind of distribute it. So, I have 27 to the 2/3, and I have x to the 2/3. Okay, just relax. The 2/3 is going both to the number and to the variable. Josh, can you wake your neighbor up, please? Oh, you are awake. Okay. All right. So now what we're going to do is we're going to kind of split this. All right, so draw a line, split it. We're going to worry about x to the 2/3 later. Okay, so let's take care of the 27 to the 2/3 power. Now, 27 to the 2/3 power, let's write that in radical form. That means I'm looking for the cube root of 27 squared. Are you guys okay with that so far? Because I only have a number there. I don't have a number and a variable. Now, what does 27 squared mean? 27 times 27. So let's rewrite it like this. We don't need our calculators yet. So those of you that are clicking buttons, stop. Write it down like I am. Now, can you break 27 down? To what? 9 and 3. Can you break this other 27 down? 9 and 3. Can we keep going? Break down what?
9.
Okay, so 3 and 3. 3 and 3. It is a lot of 3s. Let's go back. We're looking for a group of 3 things. Right? That's what my root tells me. So I have a group of 3s here. And I have another group of 3s, right? Because I'm looking for 3 things in my group. Is everyone okay to this point? Any questions to this point? Okay, so for every group, we write it how many times? Once. So I have how many groups? 2 groups. So I'll write 3 times 3. Remember, for every group that we circle, we write it 1 time. So I have 1 group of 3s and a second group of 3. So I have 3 times 3. Now, we can't do anything with x to the 2/3 right now, so we're just going to leave it as x to the 2/3. But what is 3 times 3? 9. So this becomes 9x to the 2/3. That would be my finished answer. Okay, so we're going to do 3 more examples and you're going to be in great shape. Let's work on example 10. So the first thing to do is to separate it out, right? So you're, quote, kind of thinking about distributing. It's not quite distributing, but you're going to do 81 to the 3/2. And then you have n squared to the 3/2. Now, if we take care of the variable first, because in the other one that we just did, the variable did not have an exponent, right? That x was just by itself. But here, my n has a squared. So when we do 2 and 3/2, what are we actually doing there? Are we adding, are we subtracting? What are we doing with the 2 and 3/2? What are we doing here? That's a multiplication problem. We're multiplying. We would add it if the 3/2 had a variable. So 2/1 times 3/2. 2/1 times 3/2 gives me 6/2. And what's 6/2? 3. So this is really reduced to n to the 3rd. And I'm going to leave that. Okay? And I'm going to come back to it. Now let's work on the 81. Let's write it in radical form. So I know the 2 comes out. And I can write the 2 if I want to. How many 81s do I have in there? Anyone agree with Darius? I have 3 81s in there. All right, I have 81 to the 3rd power, which is the same as doing 81 times 81 times 81. It is a very big number. That's why we're not using our calculator. We're using our brains. Now, before you get going, let's pause. We're looking for a group of 2 things, right? Do I already have a group of 2 things? I have 2 81s. Do you guys see that? I already have 2 81s. So let's not make life difficult. I already have a group of 81s. Now, if I wanted to keep finding more groups, what could I do? Break down the, good, 81. And 81 breaks down to 9 and 9. Now, I could keep going if I wanted to, but again, aren't I looking for a group of 2 things? Do I have a group of 2 things here? So for every group, we write it how many times? So I have 81 times 9. Or I have a group of 81s, I have a group of 9s. Now you may use your calculator. 729. Can you silence that, please? So I have 729. What else am I missing? My n cubed. Okay. Questions about number 10? All right, let's try number 11. So again, we're going to separate it out. 36 to the 1/2. And then x to the 6th to the 1/2. Okay, you can work it out. Don't just stare at the board. Remember, this is 6/1 times 1/2. And 6 over 2 is 3. Okay. So you have 2 over 1. Or you should have 1/2. You're looking at what you're doing here. 6 is over 1. Raise to 1/2. Yep. Okay, now go on. Okay, so I see on your paper we're getting x to the what power?
Third.
X to the third power. Okay, so I have x to the third power. So now we'll pause there and let's go over and deal with the 36. 36 to the 1/2 becomes what as a radical, Elena?
36 squared. Or, the square root of 36.
There you go, square root of 36. Now, let's use our brains. What is the square root of 36? 6, right? We don't really have to break this down, we know. So I'm going to combine the 6 and the x cubed to make 6x cubed as my answer. Woo, woo!
So is there multiple ways, or is this the way you have to do it for this one?
No, there are multiple ways, but
Also, because this is really confusing.
yes.
I thought we were looking for group 2.
Okay, so you break 36 down to be 6 and 6, right? And then you have a group of 6s.
I took it further than that.
Did they ask that say right to me?
There's a paper towel right there. Okay, try number 12. Okay, so, Darius, you asked, there is only one group of 6s, right? So you only write it one time, which is why I only have 1 6 up here.
There's only 136, we're saying.
I thought you said, yeah, there's only one. I thought you were looking for 2 pairs.
I only need one pair. Okay, let's look at this again. So this is saying I'm looking for the square root, right? It's not 2. Okay, yeah, okay, you're right. Square is 2. So then I have 6 and 6, right? So this is a group. Do you agree with that? I can't go anymore. I don't have anything else to add because the 1/2 means that there's only, this 1/2 means that there's only 136 inside there. Let's work on number 12 and see if we can come back, okay? You gotta bring this over. 7 equals 0, right? What are you getting for the variable? X to the 9th?
No, it's 6.
Should be 18 divided by 2. You have 6 times 3 is 18 divided by 2. Okay, and then I'm looking for the square root. How many 49s do I have? Everyone agree I have 3 49s in there? Okay, so I have 49 times 49 times 49. So Darius, I'm looking for a group of 2 things, right? You agree that I have 3 49s in there because this was to the 3rd power? Okay, do I already have a pair of something? 2 49s. Okay? Then what do I do with this other 49 over here? Okay, so we'll go what? Perfect. And I have a pair. Right? So for every pair we write it how many times? So I have 49 times 7. 343. I hear a couple of you saying 343. Yeah? Okay. So I have 343 x to the 9th. Raise your hand if this is what you have. Does anyone have any questions on that?
We have to do both ways on the test.
I'll look at yours and see how we're doing. Okay.